All right, so thank you for joining us. Today we're having Dr. Aquib, who is a fellow from the NASA Habitable World Survey Group. And thank you for coming.
Thanks, Ethan. So yeah, I'll add a little bit more to that introduction. So yes, thank you so much for. Should I stand here or can? Just 10 seconds on the intro. I mean, I do wear a lot of hats, but what I'm going to talk to you guys about mostly is the work that is sort of related to the AI ML efforts around the Habitable Worlds Observatory mission. So I am a part of the AI and ML working group, which is exploring ways to deploy AI and ML-based solutions for various use cases across the mission. My primary affiliation right now is that I'm a project scientist at the National Center of Space Science and Technology Center in the UAE, and I'm also a faculty member at that university. I also guide the UAE on a number of their space projects and their talent development program. But then, today I am here to kind of discuss with you and, perhaps get some interest on the kind of work that we are doing for the AI and ML group. So what actually is, before I go to the next slide. So, let me just show you the slide first. So, the next flagship mission that NASA is, working on at the conceptual level is called the Habitable World Observatory. So that's the next big thing after James Webb Space Telescope. And it is primarily going to focus on finding habitable worlds, as the name suggests. But then, obviously, an instrument which would be, a futuristic one, and it's going to come after JWST. So it would it would not be wrong to say that it would be capable enough to do all kinds of astronomy, not just exoplanets or not just looking for habitable worlds, but it would be able to do, let's say, for example, transient astrophysics or look into galaxies and so forth. Let's see if it works. So I think what happened is that this time, as NASA started to develop the concept for this mission, they put together. I mean, it's a long story, but in short, they put together an AI and ML working group, and amongst others. So the primary function of this group is to explore ways how artificial intelligence and machine learning can facilitate various aspects of the mission, and whether it is mission design and operation, data analytics, or even flight dynamics, or whatever aspect you can think of. So that group is now tasked to find ways in which we can actually deploy that. So I think people started to think about, what sort of use case can you think of? But then the approach that people are following right now is that they're looking for use cases under different umbrellas. This is something that I believe, or I hope that it will emerge into that, this is kind of like a system approach that you kind of identify all kinds of AI and machine learning capabilities that you want to deploy. And then a big part of the work is data conditioning, that how would you pre-process that data which you would want to process, you want to, deploy AI and ML on. And then finally, you will have to have some kind of a deployment mechanism. And that is what my primary focus is going to be, that how do you go from thinking of a use case and imagining what AI and ML can be used for, and then take it all the way to deployment and serving the models and serving whatever that thing can do for you, in any area. But I think that what I have figured out is that if you think about the deployment of AI or machine learning in any kind of, let's say, use case or function that you want to imagine, in fact, the machine learning and the AI part is as small as a red box that you see, right? One way to imagine it is that, we are living in a time when, with this recent emergence, or I should say re-emergence of AI, has led us has led all of us to try to harness the power of AI in our own work. For example, an astronomer working in a certain branch of astronomy would like to solve their problem with AI and ML. For example, you're looking at light curves of exoplanets, or you're looking at time series of data on gamma ray bursts, or something like that. But then you're tackling these individual problems that you can demonstrate that can be facilitated using AI or ML. But if you're thinking about a system level or organizational level deployment, where you are kind of the AI and ML capability actually permeates across the entire landscape, in that case, setting up everything around it is a much bigger task than deploying machine learning or AI itself. So this is what, the way I am processing it in my mind. And I think that this workflow just mentions what exactly I just said. So what I'm going to do today, so I'll bring you back to this one. So let's take the HWO as a case, and let's think about how AI or ML can facilitate or can actually accelerate various kinds of operations and development when we talk about HWO as a whole mission, not just one component of it. Okay, so I have some data on some astronomical target, and I will demonstrate that how AI and machine learning can help it. Let's think about if you have an entire mission, starting from mission design to orbital design to instrument studies and to data simulation and so forth. How would you think about deploying AI and ML capability all across the mission landscape? So, I mean, I think I don't need to talk a lot about that, because this is something. I mean, these are the kind of specifications that are being considered for HWO, but that's not my subject today. So the AI and machine learning working group for the HWO actually was divided into these, let's say, 5 segments. Okay, so let's talk about these sub areas where we can think of specific use cases where we can demonstrate that AI can be helpful. So starting from mission concept and technology development, to mission operations, to data processing and analysis, all the way up to, let's say, community development, and also not to forget overall mission effectiveness. So if you process all of these 5 areas in your mind, what comes to your mind? What you would imagine is that it is like, it won't be wrong to say that it is deploying AI and machine learning for everything that's possible. Starting from designing a mission that needs to fly in space and look at exoplanets, all the way to instrument trade-off studies or instrument design and so forth. And once it's there, mission operations, right? Onboard data analysis, anomaly detection, and so forth. Once you start to get data from it, atmospheric composition of exoplanets, how do you get that from the data? Data mining, pattern recognition, overall mission effectiveness, that is how exactly various functions of the mission could be made more effective. For example, you always have this flow of information going across an organization or a mission, let's say. Then you would have to have this documentation control, right? You will have to have, documents that are required to be managed, and they will have to be accessed in a way, and they will have to be used in a way that actually makes sense for the mission. And so how about we bring in generative AI to help with that? So again, what the picture that I'm trying to give you is that it is every possible use case of AI or ML that you can think of that can be covered within the gambit of these 5 sub areas. I'm not going to go through everything. I'll just show you 3 or 4 which I try to work on, just to give you an idea and leave you with a sort of a conclusion that I think that is the main point that I would like to leave you with. So this mission doesn't exist as of now, right? So the kind of data it will have, so we don't have data that is being produced by this. So let's imagine that I want to see how can I best utilize machine learning to process exoplanet data, for example. So the first obvious part was, let's take a look at the existing data. So I started taking a look at these 4 catalogs: Exoplanet Orbiting Database, Extrasolar Planets Encyclopedia, NASA Planetary Systems Composite, and the PHL, which is this one, Habitable Worlds Catalog. So I try to see that given this, parameter space, what is it that can be solved using machine learning? Obviously, there are a few things which would come to mind without even thinking too much, right? So, for example, first you can just deploy some unsupervised machine learning to get some initial insights from your parameters. For example, these databases have as many as, let's say, 300 to 200 or 100 even, so between 100 to 300 parameters. So that is quite a lot of data. We can try to get some initial insights by deploying unsupervised machine learning, let's say by something like clustering or dimensionality reduction. So then I started, so remember I showed you an AI system architecture diagram that could be, implemented or that could be thought about. So I am now going to show you how I am kind of tackling some of these problems and how it will eventually can be components of a larger system. But the disclaimer is that I am not advocating, or I'm not affiliated with any of the tools that I'm going to show you. It's just a way to showcase and demonstrate, because I'm going to take the names of many different tools that are available around. But yeah, I have no connection whatsoever with them. I just use them. I just wanted to show you some work that can be done with those tools or some other. So I think there's something that I found to be very useful. So the first thing that you can think about, or that we can think about, is you have like a core platform where you would deploy your machine learning or AI models, and then you pass your data through them and something would come out. So I used a platform called Python Anywhere, right? I thought that it's just a platform like any other cloud-based platform, but what I found to be very useful is that it actually takes a lot of things out of the equation. For example, it provides you the hosting of a web interface, a lot of the other technical IT related stuff already taken care of on that platform for you. So what you have to just worry about is your AI and machine learning backend, which is in Python Flask, which you can, and then the app interface, which could be, let's say, HTML. And then you just deploy it, and you would see how conveniently you can manage this kind of like an ecosystem with just one dashboard, and then there is a cycle or a loop that your data goes in, it passes through this AI ML funnel, and then it comes out, the outcome comes on the other end. Let me give you an example of that. So this is an example of a tool that I developed. This is use case one, let's say.
If you click the that little button dash.
Which this one?
Yeah.
It will go. Okay, thank you. Right. So this is one example. So it is deployed using the Python Anywhere ecosystem that I showed to just show you. So this is a demonstration that is kind of like an end-to-end platform, end-to-end pipeline or a workflow that starts all the way from capturing the data from wherever it is. It doesn't have to, so it's you don't have to download that data or put it on your computer or anywhere. It picks up the right database and it picks up the right columns, and then it deploys machine learning, unsupervised learning algorithm on it, and it gives you a very first crude clustering operation. And this clustering operation is performed on the star and exoplanet radii. That what kind of clusters would you see if and you know you can see that 3 clear clusters are emerging from this data, which can give you some idea that there are these exoplanets which are, you know, in this range up to star radius of 2, solar radii, and planet radius of 0.5 radii. Then there's a group here and then group here. So it's just one click of a button, and this whole workflow takes you from raw data all the way to taking a look at, you know, what kind of patterns do you see, and how some of these objects in there can be grouped together. It's a very simple example, but it's an end-to-end workflow, you can say. That it starts off from capturing the data, it picks the right data, it sorts them out, there is some pre-processing going on, you select the features, you select your you select your features that you want to use, and then this is actually deployed using scikit-learn and k-means, and then obviously in place of that, there are a lot of other things that you can do. You can try dimensionality reduction and so forth. So, but this is again a very it's a very, I think, simple and powerful way to demonstrate that you could deploy pipelines like these, which would do the initial pattern recognition or anomaly detection or classification. It's a simple classification problem. And this is deployed without, getting a subscription to something like Amazon SageMaker. It is something which is a very viable kind of solution to deploy your machine learning algorithms for any kind of use case. So another example, the other example, I mean, it's using the same. So I tried working with these four catwalks. Another example is that we can put together an AI-powered dashboard, right? This is again something which could be very useful to accelerate what exactly you would like to do with your data. And this again has, the first thing is, so this is one of the things that I showed you earlier. You can do basic classification. That's one operation. And then you can go for something like dimensionality reduction or using PCA, or you can actually estimate correlations between. So I think I'm not exactly an exoplanet scientist, but again, what I can imagine is that a number of scientific operations that you would like to do with your data can be very readily carried out using all these algorithms, but then you need to have this right ecosystem for that. You can, so if you keep on doing that on the local machine or something else, or as soon as you start to scale it, it will start to become a huge problem because of the computing power that you would need and the size of the models that you want to run. And I think it is very possible that all of you might have seen all of this, but I'm just trying to bring you to a point that I think is close to my heart. So that was the first example. The second example is something called Streamlit. So how many of you have worked with something like Streamlit? No one? Okay, that's good. Something new. I thought that people might have seen this already. Streamlit. It's a very powerful and very easy to use deployment service, and it's free. Streamlit is a cloud-based platform that allows you to turn your AI and machine learning problem into a front end which can actually deploy the solution for you. So I should actually show you this example. This might be useful for you guys. The good thing is that it actually pushes HTML out of the equation. So no HTML. Only proficiency is in Python is enough. So you have a problem. For example, you want to, let's say, process some light curves. Then you want to deploy AI ML for it, but then you need a front end for it, and then you need to put your back end in front of the top, and you need to turn that into essentially an app sort of thing. So this is what it looks like. So Streamlit is a service. Backstage, you can work with GitHub code spaces. Your code runs, and your entire, let's say, code base works in the Google code, GitHub code spaces. And then it could be managed on GitHub, just like any other thing. And the front end would then be hosted on Streamlit. Let me give you a very nice example of this. And actually, I can run it for you right now. This is an example of a machine learning model deployment for target variable prediction. Let's say you are an exoplanetary scientist and you want to predict how many of the planets in my sample could be habitable. It's not something new, right? People have been doing that. But I'm just giving you an example of how this kind of a tool or a model could be deployed to serve it to the users. So this tool that I built using Streamlit, actually, let's run it in real time. I hope that it won't. Okay, here it is. So now you are going to see a live demo of it. So this actually, so this is by definition an example of how you deploy machine learning for a target variable prediction. So on using this tool, I can either grab data from anywhere, but for the demonstration purposes, it already has a file from the Habitable Worlds catalog from the Arecibo guys. So if I turn it on, just notice the speed of operation. Just notice how quickly it goes through all these steps, and then I will tell you what just happened. So grabbing data, feature selection, and this is actually an example of supervised learning. The last is the target variable, and then model parameters, performance, predictions, and finally a comparison with the actual labeled data. How many seconds will it take? Probably 15, 20. But now I have a model which is ready to be deployed for unseen data like this on Streamlit. So now let's say, for example, if a mission is launched and I get this data from wherever, I have this model which I can deploy in the same platform, and that should be able to predict the habitability of the planets in the data, so in the catalog. So let me just show you this quickly. So there are some parameters that the feature that I use for this, let's say the surface temperature, habitable zone, optimized range or whatever, the mass of the planet, gravity, and the conservative habitable zone area, right? And then there is some statistical estimation of how good the predictions were, right? But then you can see that it just ran in a jiffy. And then obviously, which I did not talk about, there are a number of parameters that you are able. So I did not have to write any HTML code or any front end for this at all. There are functions and built-in features on Streamlit that will allow me to do that very easily. One example, and then I think I would get to the conclusion. And I think this is something that I should ask you again. So anyone tried out building apps on Hugging Face? Ooh, I'm giving you something new then. Thank God. Python Anywhere, that was one. Streamlit, now Hugging Face. Another very powerful platform where you can deploy your own tools and apps using, actually, Hugging Face is much more powerful because it has over 100,000 models available on it. Let me give you a Hugging Face example. Hugging Face is a platform that actually hosts a lot of models which people create all over the world, including Llama, Meta Llama, or GPT models from OpenAI, or Mistral models from Mistral, obviously, or Google model, Gemini, so forth, whatever model. And again, if you are into various classes of these models, generative AI models, transformers, or whatever, you can find all of that on the Hugging Face platform. And up to a certain level, it's free. Beyond that, if you want to train your model for something specific, and you want to use their GPU service, they will start to charge you. But anyway, let me just show you how you can easily use it. So you will see that why I'm showing you this, I want to make a point in the end. That's why, but again, if there's something new to you, then that's good. You got something which might be useful for you. But again, the point is coming later on. Hugging Face, okay. So on the Hugging Face platform, you have an area, which is your own area. It's called Hugging Face Spaces. These are spaces where you can actually call out all the models that, or most of the models that Hugging Face hosts, and then you can build interface to deploy, or the word I'm using, I should use is operationalize a model. That how exactly it's going to work on your data. So Spaces, Hugging Face Spaces is the ecosystem or the platform on which you can do that. And the way it works is that, again, the same thing. You have the Hugging Face platform where you do the development. You can just imagine it as a dashboard. Then you got your AI machine learning backend, which you can have, similar to a Git-like structure, right? Where you have your app file and you have all your dependencies in one place. And then obviously, you can integrate this with two different type of modules, either Streamlit, which we saw earlier, or there's something called Gradio. It's also similar to Streamlit. It offers you to build these powerful front ends without knowing any HTML or CSS or anything else. So because the reason why I found all of this out is that without being able to serve your model, without having the front end, there's not much you can do with it. I mean, there has to be an interface, right? So what I did is that I used this platform to build another example. That's actually a Hugging Face deployment. This is a deployment which uses NASA's encoder, which is an encoder that turns text into embeddings. And then I combined it with GPT-4, which is what you would know that the OpenAI's most powerful model yet, GPT-4. They also have GPT-4o, but I use GPT-4 for this one. So what this is doing is that it is invoking or bringing these models in, and since the NASA model has been trained on NASA specific data, so it's a very powerful, it can be a very powerful tool to actually retrieve the right information on a specific subject that you're looking for. An encoder cannot generate text, so you have to pair it with a GPT type thing, so something which is an autoregressor or something like ChatGPT, a text generator. So what I did here is that I combined them, and this is kind of like a chatbot. I mean, it's a basic demo. So what I can do is that I can set all these hyperparameters here, the model parameters, and then I can ask it a question and deploy the encoder from NASA at the same time. So instead of operating like ChatGPT would, right, that it will get stuff from the data it actually learned from, it would actually grab the context and the information from the encoder. It will combine that and it would generate the text to give you the information from the NASA encoder. So this is a use case for, let's say, something which is specific to an area, exoplanets, gamma ray bursts, pulsars, whatever you work on, right? So you train a model on, you take a base model, right? Base model, which is trained on some generic data, and you train that model onto your specific data, and then you can turn it into an encoder and you can deploy it again. So the emphasis here is that without transitioning from having all of this in your code or whatever to deploying it, I think it will not be as effective as you would like it to be. That's the fourth example. And then, in addition to that, what I'm exploring now, beyond these few examples, if you really have to scale things up, right, then obviously you have these more commercial, larger scale commercially available ecosystems. You got Amazon SageMaker, right? They allow you to do the deployment, but so none of this stuff is free, right? You got Google Vertex AI that also allows you to actually fine-tune, train, and deploy your model, whether it's an ML model or a Gen AI model, whatever. And the Hugging Face platform that also has its own training functionality, which is called auto train. And this is something just very powerful. I highly recommend. Actually, let me show you really quick. So it actually starts off really cheap, but then it becomes very expensive as you start to scale up. So this is something that everyone needs to figure out, that how far would you want to go with this deployment kind of stuff anyway. Let me show you really quickly. So this is my Hugging Face account. So you can see that, I can actually virtually without having access to and without owning anything, I can deploy all kinds of GPUs or NVIDIA clusters of GPUs or whatever I need. I can just do it by clicking a few buttons, but then it will cost money. So you can choose you develop your software, which is in the Hugging Face spaces, and you deploy your hardware, which you would like to train your own model or something specific. So it depends on what size of data you're using and what number of parameters. It depends on many things. But again, it offers you an entire suite of services. This is NVIDIA or Google TPUs, which is tensor processing units, whatever you want, you can do it here. Anyway, the point that I'm going to conclude with. So this is the kind of but I think what I'm kind of advocating or trying to talk to people about is that a better approach to do this is to kind of imagine a deployment at the system level, not at the level of the task or the problem itself, right? Let me give you an example. This is some doodling that I just did before coming here, right? So let's say that we have been talking about Habitable Worlds Observatory as an example. But take any example, Hubble, James Webb Space Telescope, Chandra, whatever example you want to take. And you want to deploy AI ML across its operations. So the way I imagine it is that you have a central core that actually defines your problems, all kinds of categories. It defines on what aspects you're covering. In this case, for example, there's mission operations, data processing and analysis, integrated modeling, or mission effectiveness with generative AI. You can have all of that defined in a core, in a central core. But then if you start to solve individual problems and tasks and start to build from that, that would soon become very difficult. So what I'm trying to talk to people about is an approach where you identify that, and then obviously, as I showed you earlier, the ML and AI operation itself would be a tiny part of it versus deploying the whole ecosystem around it. You have to think about the ecosystem that will enable that operation, just as we saw much earlier. And then it doesn't matter if it is NASA Science Mission Directorate or if it is Harvard CFA. So you will deploy it across the competencies or whatever you want to call them. But let me just take you back to here, right? So I think that the examples that I showed you, you can imagine them as individual problems solved. But I realized very quickly that if it will start to become very messy very quickly. It needs to be harmonized in a way that all of this Hugging Face API or the Streamlit platform or the Python Anywhere thing, they will have to be brought together under an integrated ecosystem. And I think I would probably, I've taken so much time already. There are examples of that. For example, there is a group at MIT with their collaborators. They're trying to do something similar, which is an ecosystem as a service for healthcare, for example. They are thinking of something called clinical AI, something that integrates all kinds of health services and facilitates each and every stakeholder to get a better experience. So I was thinking, why not AstroAI? But then I am an AstroAI, right? So I'm imagining, and this is my vision, that something like this should emerge for astronomy and space sciences as well. Because just like the healthcare landscape, where you have a lot of moving parts going on, in astronomy and space science, it's the same. I mean, you can take that example too. You got space missions, you got ground operations, you got all kinds of data going on, you got thousands of institutions exchanging data, collaborating, building stuff, software. So that is a perfect use case to deploy an ecosystem as a service, not as a platform as a service, not a software as a service. It has to be thought of as an entire ecosystem, which is a crude example I gave you already is this. So I think I would leave you with just the lessons that I have learned. I'm again saying that the lesson that I have learned, that it needs to be thought of as an ecosystems within ecosystems. This is when, because a large number of us, we still do not fully appreciate where this is going and how people are going to be left out if you don't bring into your work. And I did not even talk about my other point, which is using the deployment in your own daily life. For example, I built a tool that just automates Excel sheets for you. You don't really have to do anything. Just type in natural language, remove all these rows and sum all of them up, and it will execute that for you. After the talk, I can show that tool to you as well. So it's a matter of productivity as well. How efficiently you are doing your work. This is what AI and machine learning should do for you as well. Just not deploying it for your scientific work. In your daily life, this should also help you out. And that's the purpose, that AI is not going to replace people. AI is going to facilitate people do their job better. So they're not losing their job to a robot, right? They will get to do their work in a better way so that they're not replaced. So obviously, you guys know all of that. It is all about intersection of disciplines, but what I'm saying is ecosystems within ecosystems. If you want to try any of my stuff, that's one link where all of my tools and all of my development is there for you to try out, right? And remember, it's in prototyping state. If something breaks, don't worry about it. It's still all under development. So this is what I'm talking to people about, right? This kind of an effort needs collaboration. For example, I'm not an exoplanetary scientist. I don't work on galaxies. So I would need someone like you to let me know what kind of data would you like to process. What kind of problem would you like to solve using a machine learning algorithm? Perhaps together, someone like me who is, I don't even know what I am anymore, actually. I was an astronomer. I am an astronomer, astrophysicist. But then I got interested in instrumentation. Now I'm distracted again. Now I'm doing AI and ML. So I kind of sit at the intersection of everything. So I love to do this kind of stuff that, how things can cross boundaries. But, I cannot do that alone. I don't know what a galaxy evolution scientist would like to study because I don't study galaxies, right? So for example, the chatbot that I built, I need to give it, let's say, 1,000 examples of what is a relevant question on, for example, stellar evolution or galaxy evolution. Then it will, so this tech development requires heavy input from those who are doing purely science. So an invitation, if anyone would like to collaborate on that, is interested in AI and ML, deployment, how your science can be helped by this, how it can help you in your daily life in terms of your own productivity, just grab that corner. Drop me an email, ping me on LinkedIn, we can connect, and check out the stuff that I built, which is on this website. And as I said, that it requires people to come together so that this will maybe somehow evolve into a universe AI. I don't know. But this is how it's going to evolve. It's an ecosystem within ecosystems. Thank you very much. That's it. That's what I had.
Thank you so much for the interesting talk. Do we have any questions from the crowd?
Any question that comes to your mind, whether it is how you write printf, I don't care, right? Please.
I have more a comment, a question.
Sure.
Because I heard a lot of talks, and I feel like a lot of people working with different surveys and instruments, they are building their own system to to process data. So I'm part of a collaboration, like how to visualize this survey from JWST and how to run all these things with machine learning, because astronomers have different needs. They want different things, and I feel like AstroAI people should talk amongst themselves. It's not more just it's only, as you said, galaxy people, planets people, machine learning people, but also machine learning people amongst themselves.
Absolutely.
There are so many things that astronomers are developing for different of the kind of surveys that we have or we are going to have in the next years. So I think maybe when we have too much is that a lot of people are putting a lot of efforts while instead they could just talk themselves and collaborate more.
Exactly. What's your good name?
Valentina.
Valentina. You absolutely got my message. There could be a master dashboard that actually can serve you and being agnostic of where your data is coming from. There are functionalities that you don't have to replicate at every institution or every group. This is my point. That's what I'm trying to advocate. So let's say, for example, let's take your example, that let's say there are 5 different missions, they all are getting UV, IR, visible data, and they want to do, let's say, for example, spectroscopy. Or I know that they would have, as you said, specific needs, specific requirements, science cases, and whatever. But you can distill a lot of that into very similar and common operations. For that, you don't need to deploy copies of it everywhere. For example, an initial unsupervised clustering or classification problem. Why do you want to repeat that? Or why do you want to have clones of it everywhere? You could just click a few buttons, no matter what your data is, which telescope it comes from, you can perform an agnostic classification operation. And it can immediately tell you stuff that you will be sifting through bios, as we used to do when I was a PhD student. I mean, you guys all, most of you are younger than me, obviously. So, instead of doing that sifting, you can have this unsupervised clustering operation or the, let's say, pattern recognition operation. It doesn't matter. So it doesn't matter where it's coming from. So for that kind of effort, people within a single group and other groups can join hands. And this is actually what people are trying to enable in the healthcare community, which is precisely this example. They're trying to, they say that it's very hard. If those who are interested, just take a look at this paper from 2022. But it is doable. Thanks for the comment, Valentina. It's amazing. At least my message went through. Any other questions or comment or anything? Any crazy point?
I guess I've got a couple of questions. So
Please.
if you are designing some machine learning task for a specific instrument and it does really well, but now you want to adapt it so that you want to give it to the community, but then people aren't using different instruments. And let's say you're just a small team, so you can't let people retrain it and you can't provide them the GPU back end to retrain it.
Yeah.
Is there a good ways to enable functionality where you can have the front end and then it will use their personal computational resources to retrain it?
Absolutely. That's the thing. This is the whole idea. That's a wonderful point, Ethan. Amazing. So this is the thing. You can have these front-end interfaces for your own group or your own usage. I think this is much more a game of imagining the Matrix. You guys have seen the movie Matrix. I might be so young for that. So it's you start to see it when you believe it, right? So you can have these front ends, but there could be these branches. Things could branch out in different directions depending on what that specific task is. But then you could have this core running. For example, if there's a clustering problem, you could use a model which is pre-trained for that purpose. And the dashboard there's something I didn't tell you, the guys, actually. I want you to keep it a secret, but let me just put it out. I am actually starting to work on this kind of an ecosystem already, which is this grand thing. And it would have, as Ethan pointed out, let's say, for example, it would use most of the resources at the back end, but if you have something specific that you want to train, there would be an option to retrain the model, but then it will take you to the hardware infrastructure that you will have to deploy for your own purpose, and you have to, let's say, bear the expenses or whatever, right? But then if it is already available in the repository, then you are just going to use it, because you can see that if there's a retrain, if there's a trained model or something, it is already there. I mean, you just need to do an inference on that, right? Nobody's going to charge you. I mean, if you're using, unless you're using OpenAI or Google, this is the problem, you know, even for Llama, the open source models, you have to deploy them somewhere, and they will charge you a little bit for it, but that's not a big cost. But the short answer to your question is yes, that you can have instances of processes going on, and it will branch out to the right, let's say, subsection of the ecosystem. Let's say, for example, if someone has a requirement of retraining, you can reroute them to the Hugging Face auto train, for example. But then it will be taken to the point where you have to select your hardware, because you need to retrain, you need GPUs or TPUs or CPUs or whatever. But then if it is not required, it might go to take you to a deployment which is already somewhere, sitting somewhere on Streamlit, on Hugging Face, or Python Anywhere, or anything. You had a second question on.
Yes. So I've got one question, but I've got another question is or more of follow-up. What services can let the user easily integrate their own hardware? So I think Google Colab can let you use your own local GPUs.
It can, yes.
So how would you? Do you have any recommendations for software that lets you do that?
You mean so Google Colab is one.
Yeah, and so you can just integrate Google Colab into the rest of
Anywhere, that's the thing, yeah. I mean, so you can also invoke Google Colab from within the Google Vortex AI,
Okay.
which is a part of the subgenre I'm recommending. But then, you know, the thing is that what I'm also thinking about, it is still being worked upon, but I'm also working to sort of unify this access to hardware.
Yeah.
So you can talk to people, and there could be a unified access, which is configurable, because we know that recently Microsoft and OpenAI, they're investing $100 billion on the largest supercomputer ever, gigacomputer. I don't know what they're calling it. So I am initiating discussions with people where there could be a unified access to a trunk, which takes you to all kinds of hardware that you would want to use for a purpose. But you know, all the tiny bits and pieces that are available, there's nothing that you cannot integrate with the other.
Yeah.
They are all APIs and everything, which is all around the place.
Any other questions? I was checking mine, but any questions from here? Okay. Well, I think
Right?
that's everything. Then, well, thank you so much for giving us the talk.
Thank you very much.